Hi everybody, and welcome to my talk today. I'm from Royal Bank of Canada. My name is Joshua Carroll, and I'm going to talk to you today about our capital markets journey through event-driven data that we've been working on for about the last 10 or 11 years. Quickly like to thank the EDA Summit for having me present today. Quick disclaimer. So I joined RBC Capital Markets back in 2009, right at the height of the credit crunch, based in the UK. I'm actually now based in the US. And when I joined, we were in about top 30 or so global investment banks, and we've grown considerably over the last few years. And you can see that we're based across all the sort of major sites: New York, London. We obviously have our headquarters in Toronto and other major trading cities across the globe. And we've really grown our footprint over the last sort of 10 years. And I can say that the work that we've been doing in our event-driven architecture has really helped enable the business on that front. So moving on to the next one. My team is the Shared Application Services Group, and this has really grown over the last 10 years that I've been with the organization. I started out my job here with RBC in market data technology, and middleware messaging was sort of came along with that because of the amount of data that the market data industry uses. The middleware messaging and market data tend to go very close together. But over the last few years, I now have responsibility for what we call Data Fabric, which is our big data environments, Compute Fabric, which is our Docker containerization platforms, as well as instant chat systems such as Symphony and the chatbots to relate to that, and monitoring and scheduling automation that runs across these platforms. So anything within the capital markets business for RBC that is not specific to a business unit, but is a shared platform, has been aligned into my group. And over the last few years, we've built that team out. There's about 100 people in my group across the whole globe, across Canada, US, UK, and Asia Pacific. And unlike a lot of other groups within my organization, we actually get to do everything front to back. So strategy, operations, engineering, and development. A lot of the other groups within the organization are only aligned to either run the bank function or a change the bank function. I actually get to straddle that and be involved in both. And I'm actually involved in our architecture council from a capital markets perspective too. So that gives you a bit of a flavor of what teams I have reporting into me. And now I'm going to take you on a journey through event-driven data at RBC. So what is event-driven data at RBC? So today we do about 95 billion messages a day: trades, orders, market data, internal application messaging. That's spanned across 7 geographies. And this, we didn't get to this overnight. This has been a journey of 10, 11 years. And I'm going to walk you through that journey in a minute so you can understand how we got to where we are and, how do we get to this kind of scale. But to put it in perspective, 95 billion messages a day, WhatsApp, which is probably an application you're all very familiar with, there's about 100 billion messages a day. And we've actually been almost in step with what WhatsApp has been doing. I've been doing a similar different presentation on this over the years, and I keep having to update my numbers. And as I update my numbers, so does WhatsApp get bigger, and we're very close to what they do. And to give you a bit of perspective on that too, the amount of SMS messages that travel the planet every day is only 23 billion. So it gives you an idea that my platform in RBC is doing 4 times the amount of data from a messaging point of view per day than all the SMSs in the world, and is equal to the number of WhatsApp messages that go on each day. But the size of messages on my platform will be significantly larger than just a few text messages that you might send between your friends or family, etc. So just try to put that bit of perspective. We've got 30,000 application connections, which actually relates to about 300 plus internal, external applications. We have things like our RBC DX platform, which is an external application, internet facing, or many internal applications. And across that platform, we're publishing about 50 million unique instruments that update those 95 billion messages a day. So the size of that platform, what does it look like? It's 57 appliances across production, QA, development. And we have storage connected to each of those appliances in each of those regions. And just to give a sort of breakdown of like, what does that messaging look like? It's about 10 billion messages fanned out to 80 billion subscriptions from a direct messaging perspective, and about 1.5 billion guaranteed messages a day fanned out to about 15 billion subscriptions. So you add that all up, we have this all distributed over our internal wide area network, our WAN. But we didn't get there overnight, and we obviously had to layer that in, and we Today, we're about 8 by 10 gig appliances across all these different locations, but we started off much smaller. When we started off with direct messaging, we were 8 by 10 gig back in 2010. So to get there, I'm going to give you now the journey of how did we get, how we got this event-driven architecture, how we got to 95 billion messages, and how you could do this yourselves. So moving on, but to get to there, we need to go back to the future and go back to 2010, which is where we started looking at this platform. And as I mentioned, I joined RBC in 2009. We had not impacted by the credit crunch or any of the sort of financial issues that were going on. And I spent the last 10 years of my career here building and growing platforms, hiring staff, and generally just, been able to build and grow in a way that the rest of the industry hasn't been able to do that. And again, a lot of this has been aligned to, add our event-driven architecture. Back in 2010, we had many different platforms all connected together in various different bridges. And we were stuck with a vendor at the time, which was at the time called Reuters Market Data System, RBS. It's now being renamed TREP, Thomson Reuters Enterprise Platform, and is going through another name, I believe, because that vendor has changed its name again to Refinitiv. We had TIBCO RV, TIBCO EMS, IBM MQ, 29 West, Rye Technology. So we had many different messaging platforms which are critical for market data messaging systems. But equally, one of the vendors was trying to charge us more money for our own internal data distribution. No new functionality in years, 500 plus servers globally across all the different data centers, so very large footprint. And every time we tried to do add any new service to that environment, we'd have to globally restart the entire platform. And that in itself is cumbersome. It's very painful from a rollout perspective. And if we wanted to change the schema of data that was rolling across those, what we call a data dictionary, that would affect every application. We'd spend many months trying to add new things, update a schema. It just wasn't practical. So we sat down in 2010 and we looked at, what did we want from our environment? And we were looking for things like dynamic topic discovery, so dynamic data discovery. We wanted the ability to query a cache and look for the last value of an instrument. We were looking at the ability to subscribe information without causing service degradation. A lot of the platforms we had, if you tried to subscribe an instrument that didn't exist, it would actually cause the platform to have get into a re-request state and cause you service degradation. We wanted to be able to open instruments that data would be published to later that day, but not at the start of the day, and not start, repolling to those instruments over and over. We wanted to be able to add new things throughout the day, new applications, new users, without having to restart, global systems and have downtime. And we wanted to free ourselves from our data feed vendors. So I mentioned Thomson Reuters and equally Bloomberg, now Refinitiv on the Thomson Reuters perspective. But we wanted to move our messaging technology away from our data feed vendors and really give us the flexibility of data not being tied to those. We wanted the ability to scale quickly. So those are the kind of things we were looking for. We sat down and we did an evaluation across a lot of different vendors at the time, trying to figure out, what was the best way we could get to a new architecture. And one of the, this platform that I'm going to walk you through right now, one of the sort of massive positive benefits that we got out of it was, I mentioned a 500 server platform. We've reduced that platform down by about 10-to-1 ratio. So my footprint in my data centers is actually considerably less now today, even though we've had an explosion of data that I'll talk about in a minute. So that just gives you an idea of, what we were looking for, how did we get there? So I'm going to walk you through now the timeline of how did we get to 95 billion messages that runs across our platform. So as I mentioned, 2008, the financial crisis, and I joined RBC in 2009. I'd just been working for Merrill Lynch in London, joined RBC and spent my first year actually on a plane going to places like Sydney, Hong Kong, Tokyo, living out of a suitcase, getting to know the environment and quickly growing that. And in 2010, we put our first Solus appliance live in production. It was an 8 by 1 gig appliance, and we connected that up across London, New York, and Toronto. But we equally had two different environments. So we had our fixed income environment and our global equities platform. So these are two separate platforms, all using the same technology, which is Solus systems under the covers. But at the time, as a business, we weren't connected together from a data point of view. So equities didn't want to share with fixed income, and fixed income didn't want to share with equities. Two very different siloed businesses. And as I'll walk you through this journey, you'll understand we've actually changed that dynamic now as well. So we layered in direct messaging, no guaranteed messaging day one. We spent a long time with the vendor Solace, working on a architecture that would build us for the future. It's about 100 pages long, the architecture that we designed at the time, and I still refer back to it even today. And it really has set us up for success, and I'm going to show some of the points of that architecture as we walk through this presentation today. Everything from the onboarding process, how do we tightly govern applications coming into the system, the topic hierarchy that we use, and we use this event mesh to flow data on request and on demand between regions. We added in things like last value caching, and so by that I mean you can publish an initial image that will blow away anything that's in the cache, you can publish an update to that cache, or you can drop an instrument. We added in things like an available topic API that let us look at what is in the cache at any given time from any different region. So I can be in Sydney and I can see data coming from London, all on demand, no provisioning needs to be done. It's purely based on what are you permissioned to see. We then started working on internal wrappers. So we've taken Solace's APIs and we've put some basic standards on top of those. So we wanted to be able to enforce some standards like if we have a WAN outage between regions, being able to notify applications to republish data, layering things like request reply semantics. If we have a network issue in a region, being able to force applications to reconnect. So we've built application wrappers across all the different common APIs, Java, .NET, etc., Python, C, and we've been maintaining those over the last 10 years as we've needed. As we then stepped through into 2011, we started going live, added a few more geographies in. So we added Sydney and Tokyo onto the environment, and we started layering in a permissioning system that sits outside of the Solace platform, which is called Data Access Control from an external vendor. So we can go and add users' permissions into the Data Access Control system. Those get applied to our systems, and we can make those changes throughout the day at any given time to add and provision users, whether that's an end user or an application, through a web interface. So we abstracted the permissioning system away from the appliances themselves. And then as we went into 2012 and 2013, we started layering in guaranteed messaging. For guaranteed messaging, we needed to add in a second appliance next to the primary appliance in each region. So when we first went live with direct messaging, we had an appliance in each data center, and you would be load balanced across the primary and secondary data center. When we start doing guaranteed messaging, you need to have a HA system where two appliances sit next to each other. You need to have SAN storage connected to those. And we initially went live connected to our corporate SAN for small amounts of guaranteed messaging that's obviously exploded over time. And then as we got into 2014, we started partnering with some external vendors like BCCG and built feed handlers for Refinitiv and Bloomberg data to put external data onto our platform, so not just internal pricing that flows between regions or order data, actually bringing market data prices onto the bus as well. And we actually built an Excel plugin, so in the banks, Excel is used in a way that those that don't work in the financial industry probably would have no concept of how much you can get out of Excel, what you can publish and describe. So we have many internal applications that are written, but we equally have users who are able to publish and describe data from Excel. So we wrote an Excel plugin, and again worked with a third-party vendor for that. And in 2014, there was also a book published called Flash Boys. So those who aren't familiar with RBC, I thoroughly recommend you go and read that book. It'll give you a bit of a background on RBC, our place in the market, and the spin-off of a new exchange that got created out of some ex-employees of RBC called IEX in the US. I say that book obviously actually had no involvement in that book being published. It's written by Michael Lewis, who's famous for other things like The Big Short. And, if you're trying to get an understanding of the capital markets industry, that book is a good read. And then as we move forward, we already by 2014, the 8x1 gig appliances that we put in, we were starting to hit up against the networking on those. So we were starting to upgrade appliances already to 2x10. So we were doubling the amount of network capacity on each of the appliances. At this point, I actually became the global manager for my environment and moved from London to New York as the platform continued to grow. So did my career. And then as 2015 came along, we layered in, started looking at replay data, and what we call a company called CodeStreet allowed us to record data for performance and playback. And we started looking at the amount of, with such a large system, back in 2015, we were probably doing about 30, 40 billion messages a day, something like that. We needed to have insight into that. So we worked with the vendor, Solace, on a product called StatsPump, which basically takes all of the metrics that are being produced from each of the appliances in each region, actually puts them back onto the bus for subscription. So you can store them, capture them, visualize them. Once you start publishing, billions of data, you need to be able to, have an insight or view into that. And we obviously layered in things like the Elk Stack, InfluxDB, and Grafana around, visualization of those metrics. And again, quickly as we went into 2016, you can see that we're already having to get through 6 by 10 gig interfaces. We've now gone 6-fold in the best part of 5-6 years on the amount of data we're publishing. By enabling this whole platform and bringing up every application that's been built in capital markets over the last 6-7 years at that point, every single one of them was built to talk to Solis. So we had an explosion of data, really enabling our business to start pushing data out and sharing information globally across the 6 geographies we were live at the time. And this just led to a massive amount of data, a deluge of information coming onto our platform. And in 2016, we started looking at, okay, well, how do we get better at applications and get into production? So we actually added in full HA and DR in my QA and dev environment. So every single day in my QA and dev environments, I do HA failovers, so hot standby failure. We kick over an appliance, we let the applications prove they can recover. We'd actually had situations whereby we'd had to fail over to DR in the middle of a production day because of network issues. A core network switch fails, and while the network team was having issues in the core network, we were just failed over to DR, and all the applications just carried on as normal. Very little interruption to the business by doing that. But the only way we could do that was by having full QA and DR in our non-production environments. There's not a lot of people who build their development environments to truly match what their production ones look like. And that's what we did. And I convinced the business that this was needed. And this is going to, when issues do happen, that we know comfortably in production, we're not going to have problems. And so we have your weekly HA and DR tests in non-production environments. And as we move forward in time, then in 2017, we started recording everything. So all data that came off the bus, we weren't up to that point recording everything. We started recording all the data that flows through it from a direct messaging point of view. So all my pricing information recorded. So we can, if people question a price at a later point, we can go back and look at it. And then obviously we had to start upgrading to 8 by 10 gigs. So from 2010 to 2018, we've gone from 8 by 1 gig appliances to 8 by 10 gig. We've had an explosion, almost 10-fold in the amount of data that's now going through these environments. So we've really enabled the business. And again, we added yet more visualization of data with another vendor partner there, CJC, for their product Mosaic OA, which gives us input into the amount of daily messages and the stats around those. And we have recording on. We're able to tell every application each day how much data they published, how much that is compared to the historical metric of what they've done before. So if they're above or below their sort of watermark they've ever seen before, which server, which application published it. So we're really able to give really granular statistics for every application that flows on the environment. So if you make a change and you're not aware that your change may be double the amount of data you published, you're going to get a report at the end of that day telling you, by the way, your application's now published twice the amount of data. You were doing that. Did you intend on that? And then as we get into 2019 and across 2018, the amount of storage we needed really started to outstrip the corporate SAN capacity. And so we worked with Solis again on layering in what we call QMS, which is queue management system. And you'll see there in 2019, there's queue management system as well, which is like the encrypted version of that, which allows us to have dedicated storage next to every appliance in every region. So we've got dedicated storage, dedicated appliances across the 6-7 geographies that I'm going to show you in a minute. And then we started also redeveloping our whole desktop UI as well. So not only have we transformed our messaging environment, we started transforming our desktop platform, and we partnered with a company called OpenFin, which has become prevalent across the financial industry as a way of having a single unified desktop launcher for all your applications and how you launch all your, say, HTML5 applications through a single API. And that's all those desktop applications we started building, obviously all connected to our Solis environment in some way for data. And in 2019 and 2018, we started reimagining our whole platform and saying, well, hold on, should we even have equities and fixed income platforms anymore? We've changed how we work as a business. We're more across platform as opposed to siloed. And this is where we started putting together the idea of a single VPN. So from Solis terms, this is a virtual private network, and this is how data gets shared between the different platforms. And we started converging things down. And I'll show you in a future slide, like how we've layered the old and the new together to allow us to bring our equities and our fixed income and what we call our public environments together into a single platform. So we still have 3 physical environments, but they're now all connected together as well for a single bus, so you can share data between any of those. And then as we get into 2020, obviously the pandemic hit, and back in March 2020, we hit record volumes across platforms and saw a 40% increase year on year on the amount of data that flowed through our systems back in March 2020 as the pandemic sent the markets into meltdown. And our systems continued to cope without any issue. So we enabled the business to do very well during the 2020 timeframe by having a platform that can grow. And on any given day, we can, flex up the amount of data that we're going to send or receive quite significantly. And we have also added in things like replay. This is something that's quite commonly needed from people using Kafka. A lot of people tend to fire data into Kafka and leave it there and just want to come back and look at it later on. So by adding replay from a guaranteed messaging perspective into our Solus environment, and then we were, adjusting to meet the needs of developers around how they were using things like Kafka and use the same thing in Solus. We also allowed in something called shared subscription, which basically allows you to share data across multiple consumers in a way that in a guaranteed paradigm, you can have a queue and share data in a non-exclusive way across many consumers if the volume of that data gets extremely high. But from a direct messaging perspective, that wasn't possible. So we partnered again with Solus, came up with an idea that would allow you to do exactly the same thing in direct messaging, non-persistent messaging, where you can share data across many consumers through one single subscription. And then 2021, it's all about the cloud. It's all about Docker containers and Solus's new product around Event Portal. So that's sort of the journey of how we got through all the different things. And I'm now just going to walk through, what that looks like. So here is the overview of our event-driven architecture, our event-driven data. As I mentioned, it's 57 appliances across all the different geographies, and I'll show a quick diagram in a few slides' time on what that looks like. We've layered in 32 dedicated storage devices to each of those appliances. So where you've got a HA pair, you have a single storage device across them. That's 150 trillion bytes of data a day. We've really enabled the business to just explode on this, and we've had to put in our own dedicated WAN links between London and New York just for this platform, because our corporate WAN just could not keep up with the amount of data. We're the biggest thing on RBC's network. We've had to upgrade networks to be able to cope with the amount of data we've enabled the business with. And as you'll see in this diagram, it's a very high-level overview, just showing you we have 3 different environments that have got different VPN names, and now we've layered in this RBC singular VPN that shares data across all of them. So we've got like our classic environment and our new shared environment. That went live in 2019, and every new application that goes onto our platform now goes into that shared environment, but data can flow between the old and the new. Okay, now I just want to give a quick overview of like what are the pillars that make up our platform overview. And so, if you're building an event-driven architecture, these are the things that I think are critical for being able to do that. First of all, where we are now as a business, having a single message bus, a single mesh, and having all the data routed and clustered across all different geographies. As mentioned, we've got 7 different geographies that this is enabled across. And data being able to go on demand, so you're not provisioning things, it's all in place. Being able to be cloud ready, obviously everyone is moving towards the cloud, even in the financial industry, whilst we might be slower than other industries in being able to go out there due to the sensitivity of our data. By having Solus as our environment, and I'll show you in a few slides, we're enabled to share data to the public cloud, and we're working on that at the moment as our sort of next big step as we containerize the environment. Big data, obviously, being able to record and retain data, being able to replay it for applications. These are all pillars of being able to have an event-driven architecture. And I thoroughly recommend, putting standardized APIs out there or adapters and wrappers. That's been one of the big successes for us, is writing our own wrappers on top of the APIs that exist to ensure that even within our own environment, people are using the APIs in a standardized way. And obviously, with any massive system like this, you need to be able to visualize and monitor and capacity plan. And we've got, huge amounts of ancillary processes that are built around our messaging environment to give me those reports, to tell me the applications who are doubling their data on a daily basis. So we can give them insight into that, and also assure senior management that we've got the capacity to grow and keep continuing our platform. So moving on to the next slide, I wanted to give you just a very brief overview of our topic hierarchy, just so you can get an insight. Okay, well, Josh, what does this really look like? How are you really doing this? So we broke out our topic hierarchy by region, by business unit, by data type, and then internal application codes, application names and instances, schemas of data and content. So you can see that up there on the screen, just to give you an idea. We spent probably about a month working through this topic hierarchy back in 2010 when we first put the platform together. Because if you mess up your topic hierarchy, then trying to come back and reset this down the road is extremely difficult to do. It's like changing the wheels on a car driving down a highway. You just can't do that. So you know, spending time thinking this through, and so we've only had to make minor tweaks to our topic hierarchy over the last 10, 11 years. You know, so spending time and thinking about that, and again, we work with Solace on how do we make that look and publish these standards. And so that just gives you a brief overview. I'm not going to go into any more of the sort of detail there. It just gives you a very high level of what our topic hierarchy looks like. And then I'm going to move on. Here is a view of my environment, which I've talked about over the last few slides. So I haven't, on this slide, just for space purposes, not put all the environments. We also have Tokyo, Sydney, and Singapore, which are equal setups. You'll notice each one of these regions looks exactly the same, where we have Sol caches, which is a last value caches across production and DR, where those data is a mirror across the site, and we can cascade data to any other region. We've got the SQMS devices, so the secured QMS systems connected to each appliance. And in production, we have a HA pair and a Singer appliance. And all of that is connected up by our RBCs WAN, which, as I mentioned, we've got dedicated WAN in London and New York. Just the amount of data that we have to flow between those two financial centers is huge. And so having our own dedicated WAN has become a requirement just because of the amount of data that we're now publishing. So it gives you a bit of an insight. Again, you can imagine the Tokyo, Sydney, Singapore sites, identical setup and exactly the same, all clustered. And then finally on to last few bits around our vendor eco space. So as I mentioned, across the whole platform here, we've got many different vendors that are plugged into this. So it's, you know, Solace is in the middle of this, as an enabled us as a business, but we've got Refinitiv and Bloomberg data coming in. We've got the BCC group who's built feed handlers for us, Code Street for recording and replay and performance testing, CJC which for their Mosaic OA, which is visualization platform and data insights, ITRS for the real-time alerting, MDXT for the Excel plugins, OpenFIM for the desktop components, and then obviously the whole ELK stack there, and InfluxDB for, again, more visualization and capture of metrics. So it's not just one vendor, it's an ecosystem of vendors that sit around these that have really enabled us. And say all of these things that we've built with each of these vendors, they're all available for anyone to purchase. They're not RBC specific. They're, you know, things that we've made the vendors do that we feel are generic enough that they can sell them to anyone else. So that's really enabled us as a business. And then I just want to finish today with a quick sort of, you know, where are we, where are we going, and give you a quick oversight into what does it look like for the future. So the here and now, I mentioned cloud a few times throughout the presentation. As we have appliances that live in our DMZ today that enable our RBC DX application. And so we're using those appliances to start bridging between what is the public cloud, AWS, Azure, and Google's GCP, to send data internally and externally. So we might be generating data externally in, say, AWS. That might stay in AWS and never come back on premise, depending on the requirements for that data. Or equally, we might be sending data from on-premise applications out to the cloud. And as we start to move workload out there, workflow will move with that. And obviously, those aren't appliances. They are the Dockerized version of Solace's Event Broker. And Solace themselves has a managed service, a messaging as a service of their Solace Cloud product that you can have them actually manage and look after those for you in the public cloud. Or you can spin up those event brokers yourself and run them as Docker images. So you have the ability to pick and choose, or even, you know, put the two together. And so we're working with them and our own cloud team at RBC to stand up their infrastructure of the future. And because we've got Solace as the backbone behind our whole messaging infrastructure, our event-driven architecture, it means we can easily start moving out into the public cloud without having to worry about how we move data between the two. And I'll just briefly close with the Event Portal product, which is going to give us an insight into the data flows and the application connections, and really layers on a another sort of visualization piece, and really helps you get an understanding of the lineage of your data and how things are connecting together through that event portal, which is a new product that they've been working on over the last few years, and it's just gone live. So that's something we're working on at the moment with the vendor. So hopefully everyone has got a bit of an overview of what RBC has been doing for the last 10 years. And again, event-driven architecture has become, something that's very sort of vogue at the moment. And the naming around this keeps changing. Is it mesh? Is it event-driven architecture? But, this is something we've actually been doing for 10, 11 years, and feel that even today we're still at the forefront of this whole technology. And it's been a real game changer for RBC having this platform in place, because we've just been able to unlock and share information that, with where we were 10 years ago, it just would never have been possible. If COVID had come along in 2010, we as an organization just would not have been able to cope from the amount of data that jumped year on year, 40% increase. And we were able to, carry that in our stride and enable our business to make, continue to make good inroads into the industry. So I'll leave you there, and thanks for watching my presentation.